Morning, everybody. David Shapiro here with a brand new video. Sorry I was out over the weekend. I was actually meeting with my startup team out in California, and it was amazing. We've got a lot going on. There will be more news coming. But first, we've got a little bit of housekeeping to do. So first, my Patreon goals. I'm nearly halfway to my goal of getting to $5,000 a month. If I get to that, I will disable ads forever because I think ads are a waste of time, and I always appreciate channels that don't have ads. So if you want to jump in, help me out on Patreon. It's patreon.com/DaveShap. Next up, I did mention that I'm part of a startup. We're LinkedIn official, so it's Exigent AI. You can come check us out there. Um, and the another bit of news around the startup is that we were actually accepted into NVIDIA's Inception program, which is sort of a startup accelerator. The press release is out there as well. One other bit of news is that many of you have asked about investing, and there's a lot of SEC rules about how you can pitch and request. And basically, you cannot pitch to the general public. You can only pitch to accredited investors. With that being said, there is a crowdsource platform that we will be starting a campaign with in just a few weeks. So I just wanted to introduce you to the idea of WeFunder. We are not live yet. We are not requesting investment. Need to be absolutely clear about that. I'm not soliciting any investment right now. I'm just pointing you to WeFunder so that you are familiar with this platform once our campaign is live. Okay, now on with the main part of the show. So I get a lot of suggestions. So I want to, whether it's LinkedIn or Twitter or Patreon, there's a lot of people that are following along with this long-term chatbot thing. And one thing that became really apparent to me is that y'all don't know where I'm going with this. Some of you do. If you've been with me for a while and you've read my books, you know where we're going with this. And this is not a criticism. This is just an observation. So I have written 3 books on the topic of cognitive architecture. And so basically what I'm doing is I am implementing some of these ideas in a new format, basically. So my first book was Natural Language Cognitive Architecture. It's out here on GitHub for free. It's also on Barnes & Noble. So what we're working on, and this is part of the video, I promise, because I got to tell you what I'm building and why. So what we've done so far is basically just the outer loop, right? Where there's something coming in from the environment, in this case, just a text message coming from me. And then we build the context, which is by pulling stuff from the database. We build up a corpus, and then we generate the output. So what we're going to be working on today and in the future is the inner loop, which is a separate inner loop. And I think there's actually going to be multiple kinds of inner loops. So there's going to be the real-time inner loop, which will help, kind of help the outer loop. So this will be like Raven's internal private thoughts. But then there's going to be a slower cycle inner loop for the dream sequence that I've talked about. The slower inner loop might also handle task tracking, and so the fast inner loop will be for task switching and task selection. That'll be saying, okay, this is what we should be doing, and this is why. The slow inner loop will be, okay, let's review memories and figure out what exactly it is that we've done right and wrong, and let's extract information. My second book was Benevolent by Design, which talks about the core objective functions. So some of you have commented on like, oh, well, you shouldn't have the goals in every prompt. One, okay, sure, maybe. But 2, there are many contact points with the core objective functions. So there's real-time behavior, which is, okay, if you have a chatbot that has general purpose goals, you want it to reduce suffering, increase prosperity, and increase understanding. This is the bedrock goal of any chatbot or any AGI, really, that we want to have. And I've got a whole book kind of, 1, supporting this argument, and 2, talking about how to implement it. So if you're curious about the core objective functions or the heuristic imperatives that I just laid out, that's in this book. Again, it's for free on GitHub and also paperback on Barnes & Noble if you want. Finally, there's Symphony of Thought, which Symphony of Thought is my latest book on cognitive architecture. And this one talks about how do you orchestrate a bunch of parallel processes and have them all working together. And that is kind of what we're building up to right now. Obviously, just a basic chatbot doesn't need a fully fledged cognitive architecture that's working in real time. But the ultimate goal is to have Raven basically be like Jarvis from Iron Man or Cortana from Halo, where it will be an independent, fully autonomous, like basically personal assistant, that will, it will have thoughts of its own. It will know about you. It'll have memories. And dreams, I don't want to use anthropomorphic terms like dreams can be confusing. It's not going to be a dream like you and I have. It's an offline learning cycle. So, but dream is easier to say. So, dream, offline learning cycle, same thing. Okay, with all that said, the last bit of housekeeping is I know that you are all very enthusiastic, but please don't submit pull requests to my experimental repos. The last thing that I need is for someone who doesn't know where I'm going to like try and change the architecture. Um, so if you submit a pull request and I just close it, that's why. I have asked people to just please do a fork. And so you see there's 63 forks. So if you want to follow along and modify it, just please fork this repo. Don't submit any pull requests. And also to set expectations, this is just an ongoing experiment. I will get to a point where I get stuck, and some of you will be frustrated and disappointed. This is just the way that of experimentation goes. I've been doing this for like 3+ years on cognitive architecture, where it's like, okay, like I'll get as far as I can, and then I'll get stuck, and then I'll like usually go write a book about it, and then I'll come back to the drawing board. So, all right, with all that said, let's get into it today. So there's a few things that I've changed, and I apologize that this is smaller. But so we've got the chat logs, right? This is the main nexus where all of Raven's real-time memories are stored. So in the future, this nexus, one, we'll change the name from chat logs to nexus. Actually, let's go ahead and do that, just so that we can make it consistent with what you're reading in my books. So this is the nexus. Right now, this contains all the input and output decisions. It contains the input coming from me and Raven's outputs. Now, in the future, this will also contain all sensory information. So, for instance, if we've got speaker recognition, so it'll say, "I hear Dave's voice" or whatever. Or if we add more audio, more video, robotic sensors, that kind of thing, that should all go here. Now, one thing that might change is that, well, no, I guess the output will stay here because this is basically the stream of consciousness. Everything that Raven is conscious of, and this is what I mean by functionally sentient. If you've come across this term, Raven is functionally sentient because Raven is a sophisticated information system that has information about itself and can perform cognitive operations on those memories or on that information. So everything that Raven is conscious of, everything that Raven thinks has really happened, is here. So the nexus is the store of episodic memories. So episodic memories is, on Friday at blah, 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 this is what I did, or this is what I heard. One advantage that cognitive architectures like this have over humans is that episodic memories have timestamps, and they are verbatim, whereas our memories are not. I'm actually in early talks with Pinecone. A lot of you folks have mentioned Pinecone and Weaviate. So I'm really excited to be exploring working with Pinecone because they have the technology to help me scale Raven into the size that we need to go. Where I did some math in one of my books, and eventually Raven will have like 3 gigabytes of memories generated per day. Memories and thoughts. Memories, thoughts, observations, that sort of stuff. So it's all coming. So this is the main nexus. And then I've got a placeholder for an internal KB. So this is basically like, I got to figure out how to give Raven an internal wiki, basically, just saying like, this is what I know about the world. This is what I trust. This is where so with an internal KB, like a real Wikipedia article, it'll have sources like, this is where I heard this. This is when I heard this. This is why I believe it. Here's evidence against this idea, that sort of thing. So you'll accumulate it all together. And so this will give Raven the ability to think critically about stuff. And also this is why we need a dream sequence. The dream sequence will update these KB articles. It'll be an offline process. And so this is a kind of learning that is technically not even machine learning because it is just updating and curating data, right? We don't need to fine tune a model as long as we update and curate and extract data from our experiences. And actually, that kind of indexing or filing of memories is a big part of what our brains do. Now, granted, the way that it remembers those things is through synaptic connections. So you might say, well, you need fine tuning. Not necessarily, because what we're doing is we're approximating that filing system in our heads with static files elsewhere. So just think of it as like, okay, the pointer to this file is the equivalent of a synaptic connection in our brain. That's a real loose interpretation, but it's a good enough way of thinking about it. So you can think of learning outside of the context of machine learning. There doesn't have to be any math. All learning happens in natural language with Raven above a certain point. Then we've got notes. So we worked on notes last time, and in case you're just jumping in, I'll go ahead and show you what these notes are. So every time you interact with Raven, Raven will pull relevant knowledge or past memories, and so you see here, all the other memories are pulled in sequential order and summarized. And so this is how short-term memory works, sort of in human brains, where like, okay, hey, like you remember the beginning of this video, more or less. It's already been summarized in your head. You couldn't repeat the beginning of this video word for word, but you might be like, Dave talked about Patreon and WeFunder and LinkedIn and his startup, right? It's already been summarized, right? And that's exactly what this does, is the notes summarizes recent memories so that it is more accessible to Raven, no matter how long the conversation gets. And it summarizes recent memories, but it also searches for relevant memories that might be older. And so this is one aspect of memory, is that it's associative and it's also temporal. So those are the two primary methods that our brains use in order to retrieve memories. Is it relevant because of some similar association? Is it a physical place that is the context? Are you talking to the same person? Are you talking about the same context? And then there's a temporal component, which is, okay, what happened near that other time? Because like, say for instance, you're talking, like you're at home, you're talking about fireworks, that might remind you of July 4th, and then you remember this other time that like the dog got set on fire on accident, something like that. That's what I mean by associative memory. That's why I'm really excited to be talking with Pinecone, because semantic search is a digital version of associative memory. Okay, so we've got the notes, this is just like, I figured if we take the time and energy to summarize something, we might as well just keep it, right? Because that's an inference. So I'm not quite sure how we're going to use this yet. I think that there's a lot of value here because it says, at this time, like we did this. Oh, you know what? I actually need to add something to this. I need to add like the timestamp that this note was taken and what it was in response to. Let me add a note to do this. Let's come to notes. All right, notes, summarize memories. All right, so here's the function where we do that. So we save it here, but the info is here. So let's just add a timestamp for this one so that we know when these notes were taken. Yeah, that'll be good. So then we'll just do time, and then we'll do, I think, let's see, how do I have this? Did I import time? From time, import time. Yes. Okay. So then we just do that. Okay. So we need to add that to the notes. So this means at this moment, this was when those notes were summarized. Because here's the thing: is if you want to compare so imagine like there's this like backslide, like everything. This note was taken, and Raven only had information up to that point in time, and so then notes in the future are going to have more references. These notes will be really useful in searching for other memories, because here's the thing, this has a vector associated with it, which will give you pointers to other memories. So you see how it's all like a spider web? We're already building a knowledge graph. By recursively searching, summarizing, and then linking memories, we're creating a web of associations that you can traverse without even semantic search, right? Because I've got a UUID pointing to other unique memories. And so this will help Raven in the future reconstruct, this is what happened, here's a narrative of what happened, so on and so forth. Okay, so that's a little bit of work done. Let me do a quick time check. We're at 14 minutes. So I try and keep these to about 30 or 40 minutes. So I don't know what we're going to achieve today because I've been spending a lot of time thinking. So I'm basically just bringing you up to speed. Oh, and the reason that I'm focusing on Raven is because hands down, my Patreons asked for more stuff on Raven. So here it is. Um, I tend to, yeah. So the Patreons, it was like 7 out of 9, or vast majority of my Patreon patrons wanted more about Raven. So here we are, and this is important work. Okay, so we've got the notes. Where this is being recorded, I'm not using it yet. I'll have to think about how to use it. We're not building an internal KB yet. That's going to be created during the dream sequence. I also need to figure out tasks. So tasks are going to be updated by the fast inner loop. So the fast inner loop will be so this is cognitive control. Actually, here, let me show you this book. So keeping track of tasks on task by David Bader. Definitely read this book if you want to do cognitive architecture. So the uh, cognitive control is the aspect of our brain that says, okay, it guides behavior. It says this is what we're doing because you've only got two hands, one stream of consciousness that you can focus on. We don't really multitask. We do one thing at a time. We can task switch, which is part of cognitive control. So cognitive control is about task selection, which is prioritization, and then task switching, which says, okay, I'm either done with this task or something else of a higher priority has come on. This is the biggest thing that the inner loop is going to do is cognitive control. And then the way that it's going to keep track of it is we're going to accumulate tasks here. And I talk about some of this in natural language cognitive architecture, and then again in benevolent by design, or not benevolent, in symphony of thought. Now, what I didn't get to in those books, and I even talk about it, is I hadn't quite figured out how to store and retrieve them. I just talked about here's how we can design the tasks. So that's what I'm figuring out in real time. This will probably end up, like I said, being another book. I'll call it like Android Memories or something like that. Because I even recognized when I started on all this that that curating and updating memories for artificial cognitive entities, for ACE or ACOGs, that is going to be an entire discipline unto itself. And what you're seeing is the start of this. So we got tasks, we've got KB, and then we've got dreams. So the dreams, this is something that I realized that we were going to need actually pretty early on. Okay, so why? Why do we need dreams? I didn't bring up any like a slide deck. I didn't want to bore you with a slide deck, but I'm boring you by just rambling at you. So, anyways, let's take some notes. So, what is the purpose of a dream? So, one thing is that dreams, they are culturally dependent, and so what this means is that your relationship to dreams is almost entirely controlled by the culture that you grew up with and the cultural beliefs around dreams. So some cultures place a lot more value on dreams, and those cultures that do, one, they have more vivid dreams, and two, they remember them more. And conversely, there are cultures that don't really care about dreams, and so people from those cultures don't really remember their dreams. They're not particularly vivid. Now, that being said, you can you can influence your dreams based on intentionality. So, for instance, dream journaling will increase how vivid your dreams are and how meaningful they are, right? Dreams are, more often than not, dreams are like, there's a statistic that like most dreams are, quote, bad dreams and that they're slightly unpleasant. So most dreams are slightly unpleasant. But if it borders into frequent nightmares, that can actually be a sign of some kind of disorder. Most often depression, but if you're older, nightmares can actually be a precursor to various forms of dementia, actually, which is really terrifying. But most dreams are slightly unpleasant. Another thing that happens during sleep, not necessarily during REM sleep, but during deep sleep, is that your brain replays events. So replaying events and then learning. So I'll actually do this for deep sleep. Deep sleep. So replaying events and then learning, consolidating memories. So what do I mean by learning and consolidating memories? We love metaphors. We love allegories. We love metaphors. We love quippy little, blah. And if you're a coder, which if you're watching this, you almost certainly are, and this happens in other professions as well. But more often than not, if you're working on a problem, have you ever like woken up with the solution? There's a reason that that happens, and that is because dreaming and consolidation is a really critical, important function of sleep. Yes, like we need sleep just to let our bodies recover, but your brain cleans itself while it's sleeping, and it's also reviewing stuff and figuring out like, okay, what are my actual priorities? So let's take a look at this and figure out like what are the goals of Raven's sleep cycle or dream cycle. So one, and I talked about this in Symphony of Thought. One is review memories, learn from them. So extract. Here, I took some notes. I apologize. I need to do 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 do. I need to read the note that I took. I know this is all super unprofessional. Where did I save it? I save notes so I don't have to get out of bed. All right, so for Raven, principles, metaphors, lessons, and themes. That's it. Uh, Principles, lessons, metaphors, and themes. So what do I mean by a principle? So like a principle would be like, let's say your Raven, your personal instance of Raven learns that like, okay, or let's say mine, like Dave doesn't like like lots of chatter or whatever. Like Dave, or here's a principle: Dave prefers peace and quiet. Right? I have been able to distill some one of my major preferences to I prefer peace and quiet over like chaos and hubbub and whatever. And because of that, like if Raven interacts with me long enough, Raven could learn, oh, this is a principle. So a principle is something that says it's not like just recording an event. It's saying, okay, this is a preference. This is a principle of Dave. Or Raven can learn about himself too. So a principle that Raven could learn would be like, okay, if I do this, it might actually increase suffering, which runs contrary to my goals. So that's like the idea of principles and lessons. So years and years ago, my dad taught me how to ski, and he said, "Oh yeah, the first day you're going to fall down a lot, and then the second day you'll just magically be better than you thought you'd be, and that's because your brain replayed a lot and learned while you were asleep." So another thing that can happen during a dream cycle or for reviewing memories is extracting metaphors, because metaphors can also be really good like rules of thumb. This thing is like this other thing, and it is allegorical. So, for instance, if you've ever felt really lost in your life, where like you don't know what decisions you're making, or a lot just changed on you, like maybe you're moving, or you might lose a job or whatever, you might have dreams where you're lost, like you're trying to drive and find your way home. So that is a metaphor where you're lost on the road, which is like being lost in your life. And so by using metaphors, by one, extracting metaphors and using metaphors to kind of comment on what's going on, you can use that as a mirror so that Raven can have a better understanding of himself, what he's doing, his purpose, and so on. And then finally, there can be themes that you extract, and these themes are going to be here. Let's just put these on different extract principles, lessons. And so a theme in this case is I'm using theme in terms of not motif, which is how most people use themes, but from a writing perspective, a theme is a universal truth. And so I know you've probably heard me talk about there is no such thing as truth. It's all relative, and all we have is beliefs, evidence, and consensus. So when I say truth, that's what I mean. It's I believe this thing to be true. Here's the evidence, and there's general consensus around it. So I'll just beliefs, evidence, and consensus. And so this is one of the things like okay, through continuous observation, what can we establish as being true? So themes, metaphors, lessons, and principles. This is the point of the dream cycle. So I'll just do dream cycle, aka offline consolidation and learning. So offline consolidation and learning is not nearly as exciting as a dream cycle, but this is the point of it. Okay, so let me do a quick time check. We might not get much further than this. Oh yeah, we're at 24 minutes. So tell you what, here's what we'll do. We will Yeah, let's try a little bit. Okay, so we've got let's see, chat logs. Oh right, I renamed it Nexus. Need to update this here. So let's come here, chat logs. So every time this appears, whoops, we need to replace chat logs with Nexus. Do normal, replace all. Okay, cool. All right, because if you lose all, if you lose Raven's Nexus, it's like resetting. So remember in Blade Runner 2049 when Joie like gets like stomped on because all of her memories are in that device. That's like that would be the Nexus. All of Joie's memories of interacting with what's his name would be gone. Or in Westworld, remember when Arnold or Bernard, whichever one, like has all of his memory scrambled? That's like deleting the timestamps from all of his memories, so they're all out of order, which is a really cool storytelling mechanism, by the way. Definitely recommend you watch the first two seasons of Westworld. I never watched beyond that because I was like, this is good enough. Okay, so let's figure out. We've got our Nexus folder, and what I want to do for the dream sequence is we want to pull some at random. So I was thinking through this. We want to pull half at random, and then but we also want to bias the more recent ones because memories are going to be more biased towards recent stuff. And it also occurred to me that this might be a good use of our notes, right? So, I told you, like, I hope I really set expectations for this video because this is just me fumbling through it in real time. All right, because if we have notes, actually, here, I'll pause it for a second. We'll be right back. Okay, I noodled on it for a minute and I've got some ideas. So this was one of the reconstructed summaries. So again, these are the notes of the actual logs, and so this makes it one a little bit easier for the language model to use, and then we can distill it further. So this is a perfect example of what I meant by like distilling it. So I said, read the following notes and extract principles about the user. What are some common themes, preferences, or observations about the user? And so then it gave us principles. The user is interested in technology and the concept of the singularity. And I'll just go ahead and say list out the principles as a hyphenated list, like which will keep it nice and consistent. So it said interested in technology and the concept of the singularity. The user is interested in improving their sleep and mental and physical health. The user is looking for ways to reduce stress and sleep earlier. The user is looking for ways to improve their service from Raven. So specifically, Raven, this dream will make Raven realize what I want about Raven. Okay, so let's go ahead and save this. We probably won't get too much further than just doing some prompt engineering. So we'll do input, and then we'll save this. So we'll call this, let's see, prompt dream user. Whoops, accidentally added a backslash. Okay, so then let's change this around. Read the following notes and extract principles about Raven from it. What are some common themes, preferences, or observations about Raven? So basically, we learn about ourselves by reflecting on memories and how people react to us and what we have done. We want to do the same with Raven. We want Raven to learn what Raven is over time. Okay, so let's see. List out the principles as a hyphenated list and write them in complete sentences because this doesn't help. Okay, so that's just an observation of resummarizing. Raven is knowledgeable. Raven is interested about the users. So this isn't quite what I was looking for. All right, let's add that. So because we always wanted incomplete sentences. So we might need a different thing. So like what can we extrapolate about Raven? Principles or inferences about Raven from it. What can we extrapolate about the Raven entity from this. List out your findings as a hyphenated list like this, and write each in complete sentences. Okay, principles. Raven is able, provide advice on improving sleep. Raven is knowledgeable. So it's a lot of declarative, like this is, and that could be fine because like Raven is just responsive at this point. We're not reviewing Raven's internal thoughts. Oh, that's what's missing. We don't have interloop monologue yet. Okay, that's fine. That's fine. We'll get to that. This is going to get really complicated really fast. All right, but I like that output. So we'll save this and we'll do input and we'll do prompt dream Raven. And then some of the other things that we wanted to do were lessons, metaphors, universal truths. Okay, let's do that. Let's do lessons, metaphors, and themes, universal truths. Read the following notes and extract lessons, metaphors, or universal truths, themes from these, from them. List them out as a hyphenated list, like that's incomplete sentences. All right, let's see what it comes up with. Let's themes. Stimulants should be avoided during the day. Screens should be avoided before bed. Relaxation. The singularity is difficult to predict. Yeah, that's all fine. So these are good, like kind of general truisms. I'm not sure if I was looking for truisms. I was hoping to find like something a little bit more universal. Maybe what we do is we separate this out. So I'm going to save this because it's good, right? This is just like truisms and lessons. Read the following and come up with one metaphor to represent these notes. Let's see what it comes up with. Metaphor. Okay, it's like a jigsaw puzzle. Interesting. Provide an explanation. Let's see if that adds anything. As the conversation progresses, the puzzle becomes more complete with the user and Raven learning more about the computer systems, improving sleep understanding. Okay. That's interesting. I like that idea. It's not quite where I was hoping it would be, but this is good. And then we were working on, and this will probably be it. I know we're getting close to time. Yeah, over 33 minutes. Let's see. Universal truth. Yeah, that's kind. I think that might be about it. Yeah, because I like that we got the metaphor, um, and we can kind of distill it down like this is kind of what's going on. A lot of this, yeah, they're both left with a better understanding of each other. This is actually really good because this kind of allows Raven to reflect on this is what happened for my day. I actually really like this. So let's delete this and see if it will. It's like a journey. Okay. Yeah. Yeah. Okay. All right. Cool. So this is the advantage of having. Sorry, I didn't read it out loud. I was reading quietly. Basically, it says this is like a journey where we're on a journey together to better understand each other. Very similar metaphor to the jigsaw puzzle. I like both of those. So I think that this is actually really good. So next time we'll revisit and start figuring out how to integrate this dream sequence, how to better use these notes. Because yeah, there's a few things that occurred to me, but we need to make better use of these notes. We need to start consolidating dreams. Yeah. So I think, honestly, maybe the metaphor is enough. Yeah, we'll see. Because the KB article, instead of having dreams for that, what I want to do is have a KB article about the user. And so some of this information will be like, okay, what can we extract about the user, and then update the KB article. So okay, we'll call it a day. I really like this. I need to save this real quick. But yeah, so we'll do input, and then we'll save this as prompt dream metaphor. I think that's really what we wanted, was just like, okay, Raven, review your memories for the day and come up with a metaphor to explain what happened this day. There's a lot more that we want to achieve, but yeah, we're getting caught up, and I hope that you understand what we're working on a little bit better. Thanks for watching.